Searches for extraterrestrial life have intensified since the discovery of exoplanets. Especially interesting are planets orbiting in a star's habitable zone, where liquid water is possible on the surface, a prerequisite for life. The observation of exoplanets can reveal whether or not we have a true understanding of those processes in our own solar system. Taking a closer look at all planets will allow us to better understand our own, their geological past, the behavior of its atmosphere, and the future of its climate. Stay tuned to discover more about these impressive exoplanets. According to scientists who have observed it using the Hubble Space Telescope, an exoplanet named Hot Jupiter reflects almost no light, making it appear pitch black. An exoplanet known as WASP-12b orbits the star 1,400 light-years away and was discovered in 2008. It has been extensively studied since then, and astronomers have learned a lot about it. Because of its size and temperature, WASP-12b is referred to as a hot Jupiter. Its year lasts slightly more than one Earth day, and it is almost twice as large as Jupiter. The star's gravitational pull has stretched it into an egg shape and raised the surface temperature of its daylight side to 2,600 degrees Celsius because of its proximity to the star. In terms of mass, WASP-12b is about 1.5 times the mass of Jupiter and is almost twice as large. In addition to orbiting a star 870 light-years from Earth, the planet pushes the limits of how close planets can get to their stars without being destroyed. Moreover, the planet has a temperature that matches that of some stars. It is definitely not a star. However, since its mass is not nearly large enough to undergo the internal thermonuclear reactions associated with stars. WASP-12b is one of about 50 extrasolar planets discovered by the transit method, where they are detected when their parent star's light dims as they pass in front and block part of it. Astronomers can estimate the size, mass, and density of a planet by using the transit method. Researchers can also estimate its rough temperature based on its distance from its star, since the closer an object is to its star, the hotter it gets. GJ1214b was discovered in December 2009, and according to NASA, it's the only super-Earth exoplanet whose mass and radius have been determined. Its diameter is about 2.7 times that of Earth, and its mass is roughly 7 times that of our planet. There is a great deal of water on the planet, and its surface is estimated to be around 230 degrees Celsius, which explains its thick, steamy atmosphere. GJ1214b has unique properties that make it unlike anything seen in our solar system or any other planetary system currently known. With temperatures and pressures so high, exotic materials such as hot ice or superfluid water will form, substances entirely alien to our everyday experience. There is likely a lot of water ice present in GJ1214b, which may have formed farther from its star and then migrated into its present location over time. Temperatures would have changed to more Earth-like levels as a result, but it's unclear how long this benign phase lasted. The proximity of GJ1214b to Earth makes it a prime candidate for future studies. An even better look at the atmosphere of the planet may be possible with NASA's James Webb Space Telescope, which launched in 2018. This is a planet covered in ice and on fire. The strange characteristics of this planet, which looks like a Neptune-sized planet, have intrigued us in our search for life. Radial velocity observations have revealed Gliese 436b to be the smallest planet ever found. Furthermore, it differs greatly from other planets discovered so far. The diameter of this planet is around 50,000 kilometers, about the same size as Neptune. This means that it is about 4 times the size of our planet. Scientists have determined that the planet's surface temperature is 439 degrees Celsius, since its core is composed of iron and rock. There are 13 times as much distance between the planet and its star as Mercury is from the Sun, despite its star being much cooler than the Sun. This leads to an increase in the planet's surface temperature. It's largely made of hydrogen, but it is not dense enough to form rocks or Earth. In spite of this, water is solidified on the surface of the planet due to its great gravity and is in the form of hot ice. The density of ice is greater when it is created under very high pressure than when it is formed under normal pressure. In addition to the ice mantle, approximately half of the planet's mass is made up of water. Considering the planet's proximity to the star, it is not expected that its water would become extremely concentrated at such a close distance. This is why the planet appears to be moving from an outer to an inner orbit. Almost twice as wide as Jupiter, our largest planet, WASP-17b, is one of the largest planets ever discovered. A 20 times larger planet than Earth, it's a vast, bloated gas giant. Although WASP-17b has a much larger mass than Jupiter, it is only half as massive as Jupiter, probably caused by tides. The shell has been blown up by internal heat energy. In addition to being 1.4 times as large as our Sun and slightly hotter than our own, WASP-17b is a star of the F4 spectral type. Taking only 3.74 days to orbit once, WASP-17b orbits at a distance of 7.7 million kilometers from its star. A retrograde orbit was discovered for the first time on WASP-17b. In other words, while the star spins in one direction, the planet orbits in the opposite direction. In this case, it would be the first planet discovered with such a motion. By measuring the transit of the planet as it moves toward or away from Earth, the Rossiter-McLaurin effect of the planet on the star's Doppler signal was determined, whereby the transiting planet dampens the blue shift or red shift of either hemisphere of the star. There is no clear explanation why the planet orbits in the opposite direction to that of the star. According to some theories, a near collision with another planet might have triggered a gravitational slingshot, or a smaller planet-like body might have tipped WASP-17b's orbit. The discovery of an exoplanet outside the solar system includes rings 200 times bigger than Saturn's rings. The planet is named J1407b since it is the first exoplanet discovered orbiting J1407. J1407b has 37 rings measuring approximately 89 million kilometers in diameter. Approximately half the distance between the Sun and the Earth is covered by this value. This is almost as long as the distance between the Sun and Venus. According to estimates, J1407b is 10 to 40 times the size of Jupiter. Based on the light curve, astronomers estimate that the rings are about 200 times larger than Saturn's rings and have a diameter of 120 million kilometers. Light is blocked by dust particles that make up roughly an Earth's mass in the ring system. There may be something special about this exoplanet in orbit around Sun-like host star 55 Cancri e. Because of immense pressures and 2,700 degrees Celsius temperatures, its interior may be made of diamond, making it the first super-Earth discovered around a main sequence star. The diamond theory has lost some of its shine thanks to recent research, which has revealed less carbon than previously thought, but 55 Cancri e continues to remain an enigma. As compared with Earth, 55 Cancri has twice the radius and 8 times the mass. It is referred to as a super-Earth because of its mass, which is greater than our planet, but not more than 10 times that of our planet. Around 40 light-years away in the constellation of Cancer, 55 Cancri is a naked ice star. A radial velocity fluctuation on 55 Cancri led astronomers to discover this world in 2004. But astronomers weren't able to accurately calculate the planet's mass and radius until 2011, when it was observed transiting its star. Based on this data, as well as what is known about 55 Cancri's chemical composition, Yale researchers estimate that up to 1/3 of the planet is carbon. This carbon could even become diamond under the right conditions of temperature and pressure. It's not the only diamond planet that exists out there. Let's take a look at GJ1214b, another super-Earth orbiting a star 40 light-years away. Having been discovered in 2009, it has a diameter about 2.7 times that of Earth and a mass about 6.5 times that of Earth. Not only carbon but also water is found in abundance in it, which is something we're desperately trying to search for elsewhere in the universe. The water here isn't the same as the one on Earth. Water on GJ1214b is more likely to be supercritical fluid due to its surface temperature of around 230 degrees Celsius plus the planet's high pressures. Thank you for joining me in discovering these beautiful exoplanets. Keep an eye out for upcoming videos on other breakthrough discoveries in astronomy.